Hello dear students, all of you welcome to Vidyan classes. It is the fourth lecture on function in the chapter relations and functions. Today we will discuss equal functions and some more important problems based on injective, surjective and bijective functions. First, we will discuss equal functions. But what is the definition of an equal function? Two functions f and g are said to be equal if first condition two functions f and g are said to be equal if domain of f is equal to domain of g. Second condition, fx is equal to gx for every x belongs to dom f. That is, range of f is equal to range of g. It is the definition of equal function. Two functions f and g are said to be equal if domain of f is equal to domain of g. Second condition, fx is equal to gx for every x belongs to domain of f. That means range of f is equal to range of g. Clear? Two functions are equal if they have same domain and same range. Then the functions are said to be equal. Clear? Okay, note down. First question, elements of mathematics, exercise 1b, page number 24. Question number 5. Show that the functions f and g defined by fx equal to 2 log x and gx equal to log s square are not equal even though log s square is equal to 2 log x. We have to show f and g are equal functions, are not equal functions. At what condition f and g are equal? Two functions are equal if they have same domain and same range. Solution, fx equal to 2 log x. fx is equal to 2 log x. What is the domain of this? Log x is exist when x greater than 0. Domain of f is equal to open bracket 0 to infinity. Log x is exist when x lies between 0 to infinity. That means x greater than 0, less than infinity, which is same as r plus, positive real number. What is the graph of the function? Here E is the base. Y is equal to 2 log x. Here the base is E. E greater than 2, less than 3. It meets the x-axis at 1, 0. The domain of fx is equal to log x is open bracket 0 to infinity, and gx is defined by gx is equal to log s square. Domain of g is equal to gx is exist in minus into 0 when x lies between this interval union 0 to infinity. Logarithm function is defined when this position is greater than 0. That means s square is positive in this interval and s square is positive in this interval. So domain of g is this. The graph of this function y is equal to log s square. It is also y is equal to log s square. It meet 1, 0 and minus 1, 0. Log s square meets the coordinate axis, that is x-axis, at 1, 0 and minus 1, 0. Domain of g is equal to open bracket minus in between 0 union open bracket 0 to infinity. Domain of f is not equal to domain of g. Domain of f is not equal to domain of g. Therefore, f and g are unequal. Even though log s square is equal to 2 log x. By the rule, log x to the n is equal to n log x. Here the base is e. By this rule, this equal to this. But it does not satisfy the equality of two functions. Two functions are equal if they have same domain and same range. Domain of f is this and the domain of g is this. Domain of f not equal to domain of g. Most important problem. Clear? Clear? Next question. Elements of mathematics, exercise 1b, page number 24. Question number 4, first bit. So that the following functions are injective. The function fx is equal to sin x, x belongs to close bracket 0 pi by 2. We have to test the function is injective. By the definition, for every x1, x2 belongs to domain set, fx1 is equal to fx2, that implies x1 is equal to x2. Or for every x1, x2 belongs to domain set, x1 not equal to x2, that implies fx1 not equal to fx2. Fx is equal to sin x, x belongs to close bracket 0 pi by 2. For every x1, x2 belongs to domain set 0 pi by 2. Close bracket 0 pi by 2. Fx1 is equal to fx2. That implies fx1, fx equal to sin x. Sin x1 is equal to sin x2. That implies x1 is equal to x2. Since it is the graph of fx is equal to sin x. It is the line that is x equal to pi by 2. It is x1, it is x2. It is f of x2, it is f of x1. Fx1 equal to fx2, that implies x1 equal to x2. Therefore, f is injective. Clear? It is the graph of fx equal to sin x. In this interval, the function is increasing. Note fx is equal to sin x is increasing in close bracket pi by 2. Every increasing function is 1 1. Every increasing function is 1 1 or injective. Therefore, fx equal to sin x, x belongs to 0 to pi by 2, is injective. Is injective. Fx equal to sin x, in this interval, x2 greater than x1, fx2 greater than fx1. In this interval, the function is increasing. Fx equal to sin x is increasing in close bracket 0 pi by 2. Every increasing function is injective. Fx equal to sin x, x belongs to pi by 2 is injective. Or second definition, for every x1, x2 belongs to close bracket 0 pi by 2. x1 not equal, the figure shows x1 not equal to x2. The figure shows x1 not equal to x2, fx1 not equal to fx2. It is also the definition of a injective, where fx is equal to, where fx is equal to sin x. That is, sin x1 is not equal to sin x2. Therefore, fx is equal to sin x, x belongs to close bracket 0 pi by 2 is injective. If two images are same, objects are same. Two objects are unequal, their images are unequal. This and this are the definition of injective. So the function defined by is injective. Clear? Okay, note down. Next, question number 4, second bit. Fx equal to cos x on close bracket 0 pi. Solution. Fx is equal to cos x on close bracket 0 pi. X is equal to pi. It is pi 0. x1, it is x2. fx1, it is fx2. By the definition, it is the graph of y is equal to fx is equal to cos x. For every x1, x2 belongs to domain of f, that is close bracket 0 pi. fx1 is equal to fx2, which implies cos x1 is equal to cos x2. That implies x1 is equal to x2. If two images are same, the two objects are same. It satisfies the definition of injective. Therefore, f is injective. If two images are same, their objects are same. Or for x1, x2 belongs to close bracket 0 pi x1 not equal to x2, x1 not equal to x2, fx1 not equal to fx2, implies this. fx1 is not equal to fx2. That is, cos x1 is not equal to cos x2. It also satisfies the definition of injective. Therefore, fx is equal to cos x on close bracket 0 pi is injective. Clear? If two images are same, their objects are same. Or two objects are unequal, their images are unequal. In this interval, the function is decreasing. Every decreasing function is 1, 1. Using definition, we can prove the function defined by is injective. Clear? Okay, note down. Next, question number 4, third bit, fx equal to log x with base a, n greater than 0, a not equal to 1. There exist two cases, a greater than 0, a not equal to 1. Case 1, a greater than 1. Since a greater than 0, a not equal to 1, there exist two intervals, that is a greater than 0, less than 1 or a greater than 1. It is the graph of y is equal to log x base a greater than 1. It meets the x-axis at 1, 0. The function is increasing. Every increasing function is injective. Second, it is the graph of log x base a when a greater than 0, less than 1. It meets the x-axis at 1, 0 out of pair. In this case, a greater than 1, the function is increasing. When a greater than 0, less than 1, the function is decreasing. Every increasing or decreasing function is injective. But we have to show by the definition method. On R, we have to show here x greater than 0. The logarithm function is defined when x greater than 0. That is, x belongs to open bracket 0 to infinity. Fx equal to log x with base a greater than 0, a not equal to 1, and x greater than 0. That means x belongs to positive real number. For x1, x2, for every solution, for every x1, x2 belongs to open bracket 0 to infinity. That means R plus fx1 is equal to fx2. That implies log x1 base a is equal to log x2 base a. That implies x1 is equal to x2. Therefore, fx is equal to log x with base a on open bracket 0 to infinity is injective. Since it satisfies the definition of injective. When a greater than 0, the function is increasing. When a greater than 0, less than 1, the function is decreasing. Every increasing and decreasing function are 1, 1. Clear? Note down. Next, question number 4, fourth bit. Show that the following functions are injective. The function defined by fx equal to a to the x on real set a greater than 0, a not equal to 1. Solution: fx is equal to a to the power x on real set a greater than 0, a not equal to 1. So there exist two intervals of a. Since a greater than 0, a not equal to 1. Case 1, a greater than 0, less than 1. The graph of the function increase of x, y decreases. Y is equal to a to the x, a greater than 0, less than 1. It meets the y-axis at 0, 1. Clear? x1, f x1. x2, this value is f x2. x2 greater than x1, f x1 greater than f x2. That means it is satisfied the definition of a decreasing function. Every decreasing function is 1, 1. Case 2, that means a greater than 1. Y is equal to a to the x, a greater than 1. It is x1, f x1, x2, f x2. x2 greater than x1, f x2 greater than f x1. It is satisfied the definition of a increasing function. Every increasing function is 1, 1. For every two elements x1, x2 belongs to R, f x1 is equal to f x2. That implies a to the fx equal to a to the x. A to the x1 is equal to a to the x2. That implies x1 is equal to x2. It is the definition of for every x1, x2 belongs to R, f x1 equal to f x2. That implies x1 equal to x2. Therefore, f is injective. Since f satisfies the definition of a injective in both cases, that is case 1 or case 2. fx1 is equal to fx2, that implies two images are same, two objects are same. Clear? So the function is injective. Clear? Okay, note down. Next question. Textbook CBSE class 12 exercise 1.2. Question number 8. Let A and B are two sets so that F so that A cross B, 2 B cross A so that F of A B is equal to B A order pair is bijective. Solution. F so that A cross B to B cross A. The function f so that A cross B to B cross A is defined by f of AB order pair is equal to BA order pair. To show F is bijective, which implies and implied by F is injective and surjective. Here, to show F is bijective, that means F satisfies the definition of injective and surjective. Test for injective. For injective, let x1 is equal to AB order pair, x2 is equal to CD order pair. By the definition, for every x1, x2 belongs to A cross B, fx1 is equal to fx2. That implies f of what is x1? AB order pair fx2, x2 means CD order pair, which implies BA order pair is equal to DC order pair. Since FAB order pair is equal to BA order pair, which implies two coordinates are equal. Their respective coordinates, two coordinate points are equal if their respective coordinates are equal. S coordinate is equal to S coordinate, Y coordinate is equal to Y coordinate. B is equal to D, A is equal to C. X1 is equal to, what is X1? AB order pair. It is same as A means C, B means D, and CD is equal to X2. Fx1 is equal to Fx2. Now we have for every x1, x2 belongs to A cross B, fx1 is equal to fx2 implies x1 is equal to x2. It is the definition of injective. Therefore F is injective. Fx1 equal to fx2, that implies x1 is equal to x2. So F is injective. Test for surjective. Test for surjective. it is A cross B, it is B cross A. F is the function defined from A cross B to B cross A. X AB order pair, Y is equal to PQ order pair. F operates on X gives Y. Let X be any element is equal to AB order pair belongs to A cross B. Y is equal to PQ order pair belongs to B cross A. And F of AB order pair is equal to PQ. AB order pair is equal to F of AB order pair is equal to PQ order pair. F of AB order pair is equal to PQ order pair, which implies F of AB order pair is equal to BA order pair. BA order pair, which is equal to PQ order pair, which implies this B is equal to P, A is equal to Q. B is equal to two coordinate points are equal if their respective coordinates are equal. S coordinate, that is P is equal to B, Q is equal to A. F of X is equal to F of AB order pair Fx. X means X is equal to AB order pair, which is equal to BA order pair, which is same as, what is B? P. What is A? Q. That is PQ order. Fx is equal to F of X means AB order pair is equal to BA order pair by the definition. F of AB order pair is equal to BA order pair. B is equal to P and A is equal to Q. This is equal to Y. Now we have for every Y belongs to B cross A, there exists an element now we have for every Y belongs to, Y means PQ belongs to B cross A, there exists an element X belongs to A cross B, so that F of X is equal to Y. F of X is equal to Y. It is the definition of surjective or onto. For every Y belongs to B cross A, that means codomain set, there exists an element X in domain of F, codomain of F. For every Y belongs to B cross A means codomain of F. there exists an element x belongs to domain of f so that fx is equal to y. It is the definition of surjective. It is the definition of surjective. Therefore, f is surjective. Now we have f is injective. Sorry, f is injective. F is injective and F is surjective. Now we have F is injective and surjective. Therefore, F is bijective. Hence proved. F is bijective. Most important problem. Any doubt? We have to prove the function defined by is bijective. That means f satisfies the definition of injective and surjective. Let x1 is equal to AB order pair, x2 is equal to CD order pair. For every x1, x2 belongs to A cross B, fx1 is equal to fx2. x1 means AB order pair, x2 means CD order pair. F of AB order pair is defined by BA order pair. Similarly, it is DC order pair. Two coordinates are equal. Coordinate points are equal if their respective x coordinate and y coordinate are equal. So B is equal to D and A is equal to C. x1 is AB order pair, A is equal to C and B is equal to D. CD order pair is equal to x2. Now we have for every x1 x2 belongs to A cross B, fx1 equal to fx2. That implies x1 is equal to x2. It is the definition of injective, so f is injective. Test for surjective. F is the function defined from A cross B to B cross A. Let x be an element in A cross B and y be an element in B cross A. Y is equal to PQ order pair, x is equal to AB order pair. The function operates on AB order pair gives AB order pair gives PQ order pair. F of AB order pair is equal to PQ order pair. F of AB order pair is equal to PQ order pair. F of AB order pair is same as B order pair. By the definition, the function is defined by f of AB order pair is equal to, it is defined by f of AB order pair is equal to BA order pair. So this equal to this PQ order pair. Two coordinate points are equal if their respective x coordinate and y coordinate are equal. B is equal to P, A is equal to Q. Now fx is equal to, x means AB order pair. A is equal to f of AB order pair is same as BA order pair since it is defined by. B is equal to P, A is equal to Q, but this value is y. Now we have for every y belongs to B cross A, there exists an element x belongs to A cross B, so that fx is equal to y. It is the definition of a surjective, therefore f is surjective. Now we have f is injective and the surjective, therefore f is bijective. Clear? Okay, note down. Textbook NCERT class 12, exercise 1.2, page number 10. Question number 10. Let capital A is equal to r minus set of 3 and capital B is equal to r minus set of 1. Consider the function f so that a to b defined by fx is equal to x minus 2 divided by x minus 3 is f11 and on 2. Justify your answer. Let capital A is equal to r minus set of 3. Every real number not equal to 3. And the capital B r minus set of 1. The function f such that a to b is defined by fx is equal to x minus 2 divided by x minus 3. We have to test the function is 1 1 and on 2. Each f11 and on 2. Test for 1 1. That means injective. What is the definition of injective? For every x1 x2 belongs to domain of f, fx1 equal to fx2, that implies x1 is equal to x2. For every x1 x2 belongs to capital A. F is the function from A to B. A is the domain of f. B is the codomain of f. fx1 is equal to fx2. That implies fx is equal to this. x1 minus 2 divided by x minus 3 is equal to x2 minus 2 divided by x2 minus 3. By the cross multiplication, it gives x1 x2 minus 3 x1 minus 2 x2 plus 6 is equal to x1 into x2 minus 2 x1 minus 3 x2 plus 6. x1 into x2 cancel, 6 cancel, implies as minus 3x1 plus 2x1, that is minus x1, minus 3x2 plus 2x2, that is minus 2x2, which implies as x1 is equal to x. Clear? Now we have for every x1 is equal to x1 x2 belongs to capital A, fx1 is equal to fx2, that implies x1 is equal to x2. It is the definition of 1 1 or injective. Therefore, f is 1 1. Clear? The function defined by is 1 1. Since it satisfies the definition of injective. Test for subjective or on 2. Test for onto the function f such that a to be given by this. Test for onto. Y is equal to fx is equal to x minus 2 divided by x minus 3, which implies as xy minus 3y is equal to x minus 2, which implies as xy minus x, that is equal to y minus 1. Is equal to 3y minus 2, which implies this x is equal to 3y minus 2 divided by y minus 1. X is equal to this. For every y belongs to capital B, there exists an element, since it is 1 1. For every y belongs to capital B, there exists an element x belongs to capital A, so that fx is equal to, what is the value of x? X is equal to 3y minus 2 divided by y minus 1. 3y minus 2 divided by y minus 1, which is same as fx is equal to this. X means 3y minus 2 divided by y minus 1 minus 2, whole divided by 3y minus 2 by y minus 1 minus 3, which is same as 3y minus 2 minus 2y plus 2 divided by y minus 1, whole divided by 3y minus 2 minus 3y plus 3 whole divided by y minus 1. Y minus 1, y minus 1 cancel. 2, 2 cancel. 3y, 3y cancel. 3y minus 2y, that is equal to y. 3 minus 1, that is equal to 1, is equal to y. For every y belongs to B, there exists an element x belongs to A, so that fx is equal to y. It is the definition of surjective. F satisfies the definition of onto or surjective. F satisfies the definition of onto. So, F is onto. So, thus, in general, the function f defined by is 1 1 or and onto is 1 1 and onto. Clear? F satisfies the definition of 1 1. F also satisfies the definition of onto or surjective. Thus, in general, the function f defined by is 1 1 and onto. Clear? Clear? Okay, note down. Next question. Question number 9. NCERT class 12, exercise 1.2, page number 10. Let f such that n to n be defined by fn is equal to n plus 1 by 2 if n is odd, n by 2 if n is even for all n belongs to capital N. State whether the function f is bijective. Justify your answer. Solution: f such that n to n be defined by fn is equal to n plus 1 by 2 if n is odd, n by 2 if n is even for all n belongs to capital N. F so that n to n be defined by this. To test the function f defined by is bijective or not. We have to test the function f defined by is bijective or not. That means f satisfies the definition of 1 1 and onto or not. Test for 1 1. Test for 1 1. F is the function defined by n to n. N is the set of natural numbers. It is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Fn is defined by this. Fn is equal to n plus 1 divided by 2 if n is odd. Here 1 is odd number. 1 plus 1 by 2 that is equal to 1. 2 is even number. 2 by 2 is equal to 1. 3 is odd number. 3 plus 1 divided by 2 that is equal to 2. 4 is an even number. 4 by 2 that is equal to 2. It is not 1 1. Let x1 is equal to 1, x2 is equal to 2. Belongs to capital N. That is domain of fx1 is equal to f1 is equal to f1 is equal to 1 is equal to f of 2 means x2 fx1 is equal to fx2 fx1 is equal to fx2 but x1 not equal to x2 x1 x2 belongs to n, that means x1 x2 belongs to domain of fx1 is equal to fx2 but x1 not equal to x2, therefore f defined by is not injective. That is 1. The function f defined by is not injective. Since f is not injective implies f is not bijective. A function f is said to be bijective if it is injective and surjective, injective or 1-1. Since f is not injective, f is not bijective. The function is said to be bijective if it is injective, that means 1-1 and onto. Therefore, the function f defined by is not bijective. Clear? Okay, no doubt. Next question. Question number 7, second bit. F such that real set to real set defined by fx equal to 1 plus s square. State whether the function f is bijective. Justify your answer. Solution. F such that real set to real set defined by fx is equal to 1 plus s square. fx is equal to 1 plus s square is the equation of a parabola symmetric to y-axis passing through 0, 1 opening to above. For x equal to 0, y is equal to 1. X is 0, y is equal to 1. Y is equal to 1 plus s square. At x is equal to, it is x1 is equal to minus 1, x2 is equal to 1, it is 2, it is also 2. The figure shows the function is not 1, 1. At minus 1 and plus 1, the value is 2. We have to test the function f defined by is bijective or not. That means f satisfies the definition of injective and surjective or not. Test for injective, that is 1 x1 is equal to minus 1, x2 is equal to plus 1, belongs to domain of f that is equal to r. fx1 is equal to f minus 1 is equal to f minus 1. fx is equal to this. f minus 1 is equal to 2, which is equal to f plus 1, that is equal to x2, f x2. x1 x2 belongs to r, fx1 equal to fx2, but x1 not equal to x2. Therefore, f is not injective. Similarly, we can test for other points. Test for surjective. For surjective, what is the range of f? Range of f is equal to Rf. What is the range? The minimum value is at x equal to 0, the value is 1, otherwise greater than 1. So range is close bracket 1 to infinity, is not equal to codomain of f. It is domain of f, it is codomain of f. Is not equal to real set. Therefore, if range of f is equal to codomain of f, then the function is said to be onto. Here, range of f is not equal to codomain of f, so f is not surjective. Clear? F is not surjective. In general, f is neither injective nor surjective. That is, f is not bijective. Clear? Clear? Okay, note down. Next question. Question number 1. So that the function f such that r star to r star defined by fx equal to 1 by x is 1 1 and onto, where r star is the set of all non-zero real numbers. Is the result true if domain of r star is replaced by n with a codomain being same as r star? There are two parts. In first part, we have to show the function defined by is bijective. In second part, if domain of r star is replaced by n with the codomain being same as r star, the function defined by is bijective or not. Case 1, solution. Case 1. The function f such that R star to R star defined by y is equal to fx is equal to 1 by x, where R star is the set of all real numbers without 0. R star is equal to R minus set of 0. Implies xy is equal to 1. Product of x and y is 1. Implies x inversely proportional to y, and the graph lies in first quadrant or third quadrant. X into y is equal to 1. X and y are inversely proportional. Xy is equal to 1. That means x, y lies in first quadrant or third quadrant. Since x and y are inversely proportional, y is inversely proportional to x. Y is equal to 1 by x. Test for 1 1. Test for 1 1. For every x1, x2 belongs to R star, fx1 is equal to fx2. That implies fx is equal to 1 by x. 1 by x1 is equal to 1 by x2. That implies x1 is equal to x2. It satisfies the definition of 1 1. Therefore, f is 1 1. Clear? F satisfies the definition of 1 1. Test for surjective. Test for surjective. What is the range of the function? In first quadrant, the value of y is 0 to infinity. In third quadrant, the value of y from 0 to minus infinity. Range of f is equal to Rf is equal to minus infinity to 0 union. In first quadrant, it is 0 to infinity, which is equal to R minus set of a real number minus set of a 0, which is same as R star. Range of f is equal to R star. If range of f is equal to codomain of f, it is the codomain of f is equal to codomain of f. If range of f is equal to codomain of f, implies the function is surjective or onto or onto. Range of f is equal to codomain of f. Therefore, f is onto. F is 1 1 and f is onto. So the first part is proved. Second part, part 2. Is the result true if the domain of R star is replaced by N with codomain being same as R star? Answer no. Reason? The function f the domain of f is replaced by n. F such that n2 R star. Y is equal to fx is equal to 1 by x. F such that n2 R star y is equal to fx is equal to 1 by x. The graph lies in first quadrant. Y is equal to 1 by x. F is the function from n to R star. For every x1, x2 belongs to n, fx1 is equal to fx2. That implies 1 by x1 is equal to 1 by x2. That implies x1 is equal to x2. Fx1 equal to fx2, that implies x1 equal to x2 for every x1, x2 belongs to n. Therefore, f is 1 1. It is the definition of 1 1. Clear? Test for surjective or onto. It is the test for 1 1. Test for onto. F is the function defined from n to R star. Y is equal to fx is equal to 1 by x. The function is said to be onto if for every y belongs to codomain of f, there exists an element x belongs to domain of f so that fx is equal to y. For every y belongs to R star, there exists an element x belongs to n so that fx is equal to y is false. For example, y is equal to 2 by 5 belongs to R star. R star means set up for real numbers without 0. That means R minus set up for 0. belongs to y is equal to 2 by 5 belongs to r star. X is equal to 1 by y, that is equal to, since x and y are inversely proportional, 5 by 2 does not belongs to n. Therefore, f is not onto. For every y belongs to r star, there exists an element belongs to n, so that fx equal to y is a false statement. Is a false statement. For example, y is equal to 2 by 5 belongs to r star, but x is equal to 1 by y, which is equal to 5 by 2, does not belongs to n. So f is not onto, but it is 1 1. The first part is 1 1 onto, and the second part is only 1 1, not onto. Clear? Next question. Elements of mathematics, exercise 1b. Question number 7. Prove that the following sets are equivalent. What is equivalent sets? Note, two sets, capital X and capital Y, are said to be equivalent if or similar if mod of x is equal to mod of y, or the function from x to y is bijective. Bijective means 1 1 and all 2. If there exists a function from x to y is bijective. If f is bijective, the number of elements in x is same as the number of elements in y. Solution. It is the note. Let A is the set of 1, 2, 3, 4, 5, dot dot. B be the set of 2, 4, 6, 8, 10, dot dot. C be the set containing 1, 3, 5, 7, 9, dot dot. And D be the set of 1, 4, 9, 16, 25. It is A, it is B, it is C, it is D. Now to show. A, B, C, D are equivalent. Implies and implied by A mod is equal to B mod is equal to C mod is equal to D mod. Or there exists a bijective function between any two sets. Clear? We have to show these sets are equivalent. That means number of elements in this set is same as number of elements in this set, which is same as number of elements in this set and this set. Let f be the function from A to B. Let f be the function from A to B. Fx is equal to whatever function. 2 times of 1 is equal to 2. 2 times of 2 is equal to 4. 2 times of 3 is equal to 6. So fx is equal to 2x. There exists one-to-one correspondence between the elements of A and B. F is the function from A to B. 1 correspond to 2. 2 correspond to 4. F is the function from A to B. Fx is equal to 2x. 3 correspond to 6. And dot dot. Eg fx equal to x, Eg bijective. Implies yes, since f is bijective, A mod is equal to B mod. Similarly, let G be the function from A to C. Let G be the function from A to C. A to C. Gx is equal to Gx is equal to 2x minus 1. For x is equal to 1, x equal to 1, G1 is equal to G is the function from A to C. 1 correspond to 1, 2 correspond to 3, 3 correspond to 5, and so on. It is 1, 1 and 1, 2. That means bijective. G is the function from A to C. Is bijective. Bijective means A and C has the same number of elements. Implies that A mod is equal to C mod. X is equal to 1, G1 is equal to 1. X equal to 2, G2 is equal to 3, and so on. A mod is equal to C mod. Let H be the function from A to D. A to D. Hx is equal to S square. It is A, it is D. 1, 1 square. 2, 2 square. 3, 3 square. And dot dot. Hx is equal to S square is bijective. Is bijective. H so that A to D Hx is equal to S square is bijective since it is 1, 1 and all 2. For every y belongs to D, there exists an element in x so that Hx is equal to S square. Clear? Implies A mod is equal to D mod. Now we have A mod is equal to B mod, A mod is equal to C mod, A mod is equal to D mod. So A mod is equal to B mod is equal to C mod is equal to D mod. Therefore, A, B, C and D are equivalent. Clear? two sets are equivalent or similar if they have same number of elements. That means x mod is equal to y mod. F such that x to y is bijective. A function defined from x to y is bijective. That means 1 the function defined from x to y is bijective. That means f is 1 and on 2. The number of elements in x and number of elements in y are same. It is taken as A, it is taken as B, it is taken as C and D. We have to show these four sets are equivalent. That means A, B, C, D have the same number of elements. Let f be the function from A to B, fx equal to 2x. X equal to 1, y is equal to f1 is equal to 2, x equal to f2 is equal to 4 and so on. The function defined from A to B is 1 also on 2. That means fx is equal to 2x is bijective, implies this A mod is equal to B mod. Let g be the function from A to C, gx is equal to gx is equal to 2x minus 1, x equal to 1, g1 is equal to 1, x equal to g2 is equal to 3. Clear? So gx is equal to 2x minus 1 is bijective. That means A mod is equal to C mod. Similarly, let h be the function defined from A to D, hx is equal to s square. h1 is equal to 1 square, h2 is equal to 2 square, h3 is equal to 3 square, is bijective. It is 1 and on 2. Implies this A mod is equal to D mod. So A mod is equal to B mod and A mod is equal to C mod, A mod is equal to D mod. Two sets are said to be equivalent if they have same number of elements. Therefore, A, B, C, D are equivalent. Clear? Hence proved. Clear? No doubt?